Hello everyone. Now I am going to explain about greedy method. This is one of the important algorithmic technique. Let us see what is greedy method. Let us see the definition of the greedy algorithm. Greedy algorithm can be defined as follows. Greedy algorithm is one of the algorithmic paradigm that solves optimization problem by making the best possible choice at each step without reconsidering previous decisions, aiming to find a global optimal solution. For easy understanding, I can say like this. Greedy algorithm is always focused on local optimal decision. It always thinks that whenever decisions in the stage level in each level is optimal, then definitely we can expect a optimal result at finally. So that is what a greedy algorithm says. And it is applicable for what kind of problems? As can see clearly on the screen, it is applicable to optimization problem. What is optimization problem? Optimization problem is a problem. It is a problem where our goal is to find the optimal solution from set of possible solutions such that it satisfies certain constraints. So what are the various types of optimization problems are there? Some examples are maximization problem. Maximization problem focus on finding a highest possible value. We have some concepts like 0-1 knapsack problem, where we are focusing on maximizing the profit such that we want to keep as many as objects into the knapsack so that we want to maximize the profit. If you take minimization problem, here we are focusing on lowest possible value. Example is spanning tree or minimum spanning tree. So we have given a graph. For that we need to construct a minimum spanning tree. Minimum spanning tree is a tree where the total edge cost is minimum and which can give optimal path between any two nodes. And moreover, there exists only one path among any two given vertices. So what are the various examples of optimization problems? Here you can see shortest path problem, where our aim is to find the shortest route between two given vertices or two given nodes. Here the most famous algorithm for that is Dijkstra's routing algorithm. Another optimization problem we can consider based on greedy technique is knapsack problem. So this knapsack problem we can solve using different algorithmic paradigms. Apart from greedy method, we can also use dynamic programming. But the difference is in the knapsack problem, we are having the concept of fractional knapsack. Fractional knapsack means so we are allowed to consider part of the object over taking the entire object. Another example is job scheduling. So we have given list of jobs. Every job is having some deadline. When you finish your job, the given deadline, you are going to gain some profit. So, given the jobs and the deadlines and their profits, so what is the maximum profit we can generate? That is another problem we will see based on greedy algorithm. Finally, minimum spanning tree. So, minimum spanning tree is a tree which contain no cycles, which is connected, which is undirected, which is weighted, and our aim is to visit all the vertices of the given graph exactly once such that the total edge cost is minimized. Okay, so let us see what are the important properties of greedy algorithm so that we can understand for what type of problems greedy is applicable. So properties for greedy algorithm. This is very important. What are the two properties a algorithm must satisfy so that we can apply greedy? Okay, they are. First one is greedy choice property. The other one is optimal substructure. What is greedy choice property says that? Greedy choice property always says that the best local choice lead to global optimal. That is what. So whenever you're in a particular stage, so you in front of you there are many solutions. Let us say you're solving a problem. There are many solutions for your problem at that moment. So whatever the solution we feel optimal at that moment, you just take that. So that we call it local optimum. If you do like that at every stage, so in the final stage, after the completion of all the stages, definitely we can expect a global optimum solution. This is what greedy choice property. The other property is optimal substructure. Optimal substructure says that a problem can be divided into subproblems and every subproblem we can solve it independently. So this optimal substructure is also a property of another programming paradigm, another problem solving paradigm called dynamic programming. Okay, so don't confuse with this optimal substructure. Optimal substructure means so whatever the problem you have given, if you are able to divide that into multiple subproblems, take one subproblem, solve it. While you are solving it, as I'm telling, every problem has many solutions at that moment. Whatever the solution you feel better, take that. That is the greedy choice property. And optimal substructure means whatever the final solution we are generating. So we are thinking that this optimal solution we got because of many optimal sub-solutions we made during the previous stages. So though greedy algorithm is looking comfortable, it is having certain drawbacks. There, the first one is no backtracking. Again, backtracking is another problem solving technique. So backtracking allows us to choose a alternative solution when the current solution is not giving feasible solution. But here in greedy method, once you make a decision, you are not allowed to go back. So that's why whatever the decision you are making, please take in an optimal way. So no backtracking means once a choice you made, you are never going to revert it back. May not always work. Greedy algorithm, though we are assuming that the local in every stage some solution is optimal, but it is never always true. So that is what may not always work. Greedy algorithms fail if an optimal global solution requires reconsidering previous choice. As since we are not allowed to backtrack, sometimes maybe we have chosen a wrong solution at a particular stage. Who knows that probably that small contribution may affect a lot in the global solution. So that's why we should be very careful while we are making a decision on greedy choice property. Okay, next. So what are the advantages of greedy algorithm? We can see fast execution. Why fast execution? Because at every decision point, so we are not trying all combinations, whatever the choice, whatever the uh, choice which we feel optimal, we just go with that. Okay, so that's why it is working fast. So Dijkstra's algorithm is there. We will discuss that in the coming classes. Simple implementation. So there are few computations we are doing in the greedy approach. Example, activity selection problem. That also we will see. Memory efficient. No need to store past results. This is the biggest drawback of dynamic programming where we require memorization and tabulation. We have to store every sub problem solution into memory with the intent that maybe in future again we come across the same problem, we need to resolve it. So instead of resolving, if we are maintaining that in the database, just we can take it and we can use it. But in greedy, we are not storing it. So that's why it is memory efficient. Huffman coding is example concept under that. Works well for many problems. So most of the problems are suitable for greedy. Example, Prim's algorithm to find the minimum span, minimum cost spanning tree. Okay. Drawbacks. Though greedy is having so many advantages, it is also struggling in some use cases. They are, it is not always giving you optimal solution. Since we are taking the Local optimal decisions. Local optimal decisions is your assumption. It is not always right in the global level. So that's why may not give you optimal solution. Sometimes the optimal solution we are looking for may deviate from the expected. Example, 0-1 knapsack problem. So in 0-1 knapsack problem, we are going to find value to weight ratio of every given object which you want to keep into the knapsack. But unfortunately, sometimes when you are considering the fraction, who knows, probably we are not getting the optimal solution. Irreversible decision, since no backtracking is allowed in greedy. That's why sometimes if any decision we made wrong now, it is impacting our global solution. Traveling sales person problem. Assume any marketing guy who is having a responsibility to visit different places of a given city exactly once. It finally has to reach his office. So morning he was starting from his office, visiting different places. Every place he visit exactly once, and finally has to reach the office. If we are while he was visiting the different places, if there is no proper planning, so definitely uh, on the finally he may not visit all places. So because of that, it might impact his job also. Problem specific. So it is not always applicable. It works only if the problem satisfies greedy properties. What they are? There are two properties: greedy choice property, optimal substructure property. Okay. Next lecture we will